Hey guys, welcome back. So today, working on something a little bit different. This is a Bobcat Zero-Turn mower, and actually comes to us from a friend. He found this one on Facebook Marketplace for only 200 bucks, which is a fantastic deal. Especially when you consider the engine does run and both hydros work. So he planned on fixing this up himself, but then realized, he's in a little bit over his head, at least as far as the electrical goes. So he dropped it off, asking if we could take a look. And I did take a quick look, and the electrical, is definitely a mess. The engine that's in here, it's not original, and I don't think the wiring was compatible with it. So the original harness, I think, has mostly been bypassed. I do see lots of electrical tape and wires that are non-factory. So, at a minimum, we need to clean this up and make it safer. But really the big question he had was the PTO. As it sits right now, the PTO, which is electric, won't engage, and he really doesn't want to spend any more time or money on it unless he knows all the vital systems are good on this machine. So the goal today is going to be to get the blades to engage and get the electrical system cleaned up. So let me get this into the garage. It is threatening to rain out, and we'll dig in and see if we can't figure this thing out. So we got to get it started. It's nice we have this little starting fluid holder right here. This does have a choke, but it's not hooked up. This cable is actually too short for this replacement engine. So to start it, it's going to need a little bit of help. All right, so we made it in without too much issue. The exhaust, it is quite loud. I'm not sure if there's a hole in it. It kind of sounded like a head gasket, but I'm not seeing any signs of that either. And I did check, both the pipes are hot. This is likely the original exhaust. It looks like it was cut and welded to the replacement engine. So likely it's just leaking. Anyway, that is the choke cable that is too short. Some of the wiring disaster that we already saw. And I also tipped the seat up just so you could get a better look at some of the additional wiring issues here. We have disconnected safeties, wires pretty much everywhere you look that aren't connected to anything. So yeah, this one, definitely a bit of a mess. And just taking a look here under the machine, you can see, well, we do have a PTO with wires that are just dragging on the ground. And we have what might be the original wire harness, although I kind of doubt it. There is electrical tape. We have two blue wires going in and a couple broken wires coming out. So yeah, fixing the PTO could be as simple as that, but kind of doubt it. Yeah, so just following those blue wires up, you can just maybe barely see it right there. One of them connected right to ground, and the other one runs over here. Actually, yeah, right up into nothing. So yeah, we've got issues. I would think it should be connected to the PTO switch, which does seem to work. The question is, what is that switch doing? It must be switching power from somewhere to energize that PTO. So let's pull these bolts out and see what's going on under there. So it looks like that switch is about to fall in. We also have a broken bolt right there. So we're not the first ones here, which is no surprise. Yeah, and it's a complete mess in here. So we have a bunch of wires plugged into nothing. We also have maybe a circuit breaker of some sort. Not sure. Not much of it left. So yeah, this definitely a mess. And oddly enough, the PTO, it is plugged in to the original wire harness, which for the most part I think has been bypassed. So I think what they were trying to do at one point here is send probably power over from the ignition switch to the PTO switch, and then likely, you know, the blue wire would send power down to the PTO. So yeah, let's just test that real quick, see if we can figure out what that is. All right, I got one lead of the multimeter connected to battery negative. And let's just probe around here, see if we have positive on anything. And yeah, this blue wire we do, 11.8 volts. So technically we could connect that over here, which I think it was. And we could connect that other blue wire and then the PTO would engage. I guess the only downside is that it would engage even when the mower is off. So that key was in the on position. Let's test it now in the off position. And yeah, we still have power. So yeah, not the best way to wire it. Let's see if any of these others have power. A little bit there, 1.7. And pretty much everything else there is dead. Let's check these other wires. And those do all appear dead. So yeah, we definitely have our work cut out for us. But I'm thinking let's at least reconnect the PTO. You know, we'll try the existing wiring and at least see if the PTO works. So I did verify already that there's no power coming to these blue wires. One goes right to ground and the other one goes nowhere. So we're going to strip these back. We'll do the same over here and connect these together. So yeah, actually this was the original connector. It just got ripped off. And these wires here are obviously not the original. So I wonder why someone bypassed the entire wire harness on this machine. You know, all those wires we saw in the control panel were the original wires. So is there a bad safety, or did they want to bypass the safeties altogether? Or I would say more likely they put in the replacement engine and just didn't know how to make it all work together. So, you know, I think for now we're just gonna stay on task here and see if the PTO can be made to work. And once we've kind of worked through that issue, I think we should try reconnecting the original wire harness and see if we can't get that to go as well. So we got all the wires stripped back, and we're going to start with this one. This is the one that goes to ground. And I presume, you know, that's going to go to the black wire on the PTO. So we'll crimp on the connector, although I might shorten those wires just a bit. So I'm going to hold off actually shrinking that shrink tubing until we know the wiring's permanent. And I just pulled this out kind of want to validate what's going on here. We have a ton of terminals. And for just a simple on-off switch, I wouldn't expect all that, but I assume some of this is being used for, some of the safety systems that are currently bypassed. So we need to figure out, when we pull this out, which terminals connect together. So right now it's in. Let's just see if we have continuity anywhere. And we do from there to there, but nowhere else. Let's try the middle. And nothing from the middle. So let's pull the switch out. All right, we now have continuity between these two pins. So those are probably the pins we need. Don't have continuity anywhere else. Let's push the switch in. And yeah, so I think these are the two terminals here we need to worry about. We could test the rest, but honestly, we don't need them. So let's connect power to one of these, and we'll connect the PTO to the other. So given that the switch is kind of falling out, I'm thinking let's just pull it out and take a closer look here. So we do have 12 volts coming up here, so we have to be careful that we don't short anything out. And what I'm thinking is that we remove this jumper, and instead I'm going to use this jumper, which has a fuse in the middle, rated at 20 amps, which hopefully is enough to test with. So get that resecured. And we'll feed this wire up. And we'll send the power in through the middle. And in theory, the PTO should engage. So let's try it. Well, I was going to say, let's put the key in and try the PTO, but with the way it's wired, we don't need the key. We don't even need the engine running. If we pull this, the PTO should turn on. Let's see. Yeah, I heard a click. So yeah, I would say the PTO likely is working. So let's actually bring this outside. Let's get the engine started. Let's engage the PTO and see if the blades spin. And out of curiosity, let's see how many amps the PTO consumes. Yeah, just under 6 amps. So the fuse that's in there, it's overkill. We can definitely downgrade that. But that's going to be important later on because the charging system, I don't think is connected on this. And even if it is, I don't know for sure, if it can provide enough power to maintain that battery. Anyway, let's get this outside and see if the blades engage. I was just manually kind of spinning the belt to make sure that, nothing was locked up. You can kind of see it's been a while since it rotated. That is kind of the rust from the pulley. The more concerning thing is that the belt is severely cracked. So likely it is going to fly apart pretty quickly. But hopefully it holds together long enough for at least one quick test. the good news is the PTO, it does work, and the belt, at least it held together long enough for a quick test. So, technically everything critical here is working. The engine runs, the drive system works, and the deck engages. And really, that's all my friend wanted to know. Now, that said, everything else is more or less bypassed. There are no safety systems, no safety switches, and we also have issues down here. In the engine, we have a total of 4 wires coming out of the engine harness. One is to kill spark, which we know is working. The other one's for the fuel solenoid, which is definitely working. Then we have 2 others. One is for the DC out from the rectifier, and we also have a wire, I think it's the green one, connected to an oil pressure switch. And those 2, I'm guessing, are disconnected because we know we can kill spark and we're getting fuel to the carb. But when this wire harness comes out, it goes into this bundle of tape and only 2 wires exit from it. So in its current state, the battery is not going to charge and the PTO will not stay engaged for very long. So we do need to figure that out. And, I'm thinking we should just try to use the original harness at least as much as possible. So yeah, let's actually get it restarted as is. We'll put a meter on the battery and see if it's charging in its current configuration. So I've got the multimeter hooked up to the battery, and we're starting off at 12.09 volts. And I actually did put a battery charger on there for a bit, and then I took it off once I thought about what I was doing here, because it's a lot easier to tell if the battery's charging if we're starting at a low voltage. So when we crank the engine, we're going to see this voltage drop, and then it should quickly recover and go above, 12.1, which is where we're at now. So let's see if we can get it started. And no, not charging the battery. All right, so let's get this removed. In theory, we shouldn't have any power here. One is a ground wire, and the other one actually will send power when the ignition's on for the fuel solenoid, which, the key's in the off position, so we shouldn't have anything here to worry about. So that blue wire, I think that is the power coming from the stator on this machine and the oil sensors. So yeah, clearly not used. So let's get the multimeter on here. We'll get the engine restarted and just make sure we have power coming out of that regulator. And actually, before we start it, let's just test the green wire. That is the oil sensor. So I've got a test light. One end's on battery positive. When I touch it here, it lights up because the switch is closed. There is no oil pressure. So if I crank the engine, this light should turn off. And I've actually disconnected the spark plug, so the engine won't start either. So let's just crank it a bit and verify that the wiring's intact and that the oil switch works. Yep, it works. We have oil pressure, so that is good. So let's get the engine restarted and see if we get voltage out on the regulator. Yeah, it seems like we're not getting anything out of the regulator. The thing I find odd though is that when cranking the engine, we were getting a little bit of voltage, and then as soon as the engine started up, that voltage went to zero. So, potentially a bad regulator, maybe a bad stator. If possible, I'm going to get on the stator leads, which would be AC out, and we'll do the same test, see if we have any output on the AC side of things. So I ended up pulling out the regulator. I assume it's just a bridge rectifier inside, but I don't know for sure what components are in here. But if it is just a full bridge rectifier, then, we would have AC in, which I know these two outer terminals are the AC in from the stator, and the center is the positive out, which should run to the battery. So if we put positive in, positive input, we should get a voltage drop here on the output. And we don't. So either it's not a bridge rectifier or, potentially it's bad. Let's try the same on the other AC input. We should get a voltage drop. And in this case, we get a short circuit. So yeah, I'm going to say that this is likely bad. And if we go in this direction, we should get no voltage drop. But again, we get a short circuit. And on the other side, we should get nothing. And we don't. So yeah, we have, I think, a faulty regulator. I guess the question is, did it take out the stator? Not sure. It's definitely a little bit hard to get in here. But what I'm going to do is insert these spade terminals. Then we can test with the leads on that directly. We'll check what the resistance is of the stator, see if there's any ground faults, and then we can start the engine and see if we have any AC output. Yeah, that fitment's pretty loose. That could also be an issue. Yeah, we do have a connection here, so it's not open circuit. Though 0.3, 0.4 seems a little low, but without specs, it's hard to say. Anyway, it's not melted down, so let's see if we have a ground fault. And we don't, so I'm inclined to think the stator's actually good. Yeah, actually, I stand corrected. Pin fitment isn't a problem. I just used spades that were too small. So instead of this size, we should be using that size. So I'm going to try to start this without losing the light or the wires into the flywheel. So I've got two alligator clips here connected to the AC output of the stator. They're connected to this 12-volt light. So let's get the engine started. If the stator's good, we should see that light light up. So yeah, I would call that good. Stator's making plenty of power. And I'd say well over 12 volts because that light, I'm surprised didn't blow out. So the only other check we can do is just make sure that, the blue wire is continuous, that we don't have a break in that. So I'm going to move one of the spades over to the center position on this plug right here. And then we'll just test the wire from end to end. So we've got this lead connected to the center pin on the connector, which is the blue wire. And this is connected to the other end of that wire. So if the wire is good, we should get a beep. So yeah, the issue is the voltage regulator. Well, it's a few hours later, and I've been trying to find a diagram for this and really come up empty. I can't find anything for this exact model. I have found some other diagrams on models that seem to be similar, but those diagrams aren't great either. They are missing kind of key components and don't really explain everything very well. So I think we're kind of on our own on this one, and it's a little bit overwhelming, looking at what someone has done here. So, it's hard to know where to start, but I'm thinking we should start at the source of the power, which is the battery. So there are some extra wires here we don't need. I say we pull those off and then probably shift gears to the control panel. Most of the original harness is here. This is the plug for the PTO. It can only go in one way, so that will be easy. But we need to figure out what all these wires are and how to connect them to that ignition switch. So yeah, let's start with the source. We'll move on to the control panel and go from there. So let's start actually by pulling the battery out. We know the charging system's not working. The battery's low on charge. So I'm going to put that on the charger while we figure out the wiring. And to that end, I'm going to get rid of this wire. Despite its color, it is a ground wire that goes nowhere. And let's get the negative lead off next. And this charger wire, we're going to eliminate for now. And then we're only left with one wire. So this is the negative of the ground, and it runs straight over to the engine block. So got no issues with that. That appears correct. And on the positive, we had the other lead for the charge wire, so we're going to take that out. We have this red wire, which runs straight over to the solenoid on the starter, which is also correct. Then we have this wire. So this is obviously an add-on. This runs up to the control panel. This is what kind of energizes the solenoid, and it's not factory. So the question is, where's the factory pickup for battery positive? Don't see that anywhere. So we'll figure that out in a minute. For now, we'll take this battery out and get it on the charger. And I think the next move here is just to get all these non-OEM wires disconnected from this switch. Just noting where they went, because as it is right now, it is working, just without any safeties. So we're going to take all these wires off and just note kind of what they are. As sketchy as this setup is, it does work, and we might need to set it back depending upon how far we get. So I'm going to start by removing this wire right here. This is the one we hooked up that sends power over to the PTO switch. This is full-time power. The actual battery power is coming up through this red wire right here. It's actually jumpered over to this other terminal. So these are full-time battery positive, and I believe this one was as well. So we can disconnect all that. And that just leaves us with 3 wires. The one here on the top, that goes down to the starter. So when you hit the start button or crank the engine, that gets energized, sends power to the solenoid, and gets the starter motor to rotate. And then we're left with a black and a green. So the green, that is going to the fuel solenoid. So that's energized when this is in the run position. And the other one is the magneto. So that grounds out the coil when you shut the engine off. So yeah, I guess the question is, where is it getting the ground from to shut spark down? I'm not sure. All right, so let's solve the first mystery here. We determined that the starter to crank or energize the solenoid was this top one. And then we had 2 powers going in, which I don't think is needed. So let's see which one it should be, assuming that that's correct. So right now we're off. Actually, we were on. And when we crank, we get nothing. We turn it off, nothing. So I'm not sure what that's doing, but it's not doing what we think. And if we go over to here, which also had power coming in, we turn the switch to run, get nothing, turn it to start, and we get a connection. So it would appear that this should be connected to the battery, bottom left, top to the starter, which was correct. So these 2 were correct. So that also leaves the fuel solenoid, which would be right here. So that also appears correct. When it's off, we don't want power to the solenoid. When it's on, we get power. And when we crank, we continue to get power. So these 3 appear correct. Power in, solenoid starter, fuel solenoid. So that just leaves these 3. Now we had this one connected to the magneto, and when this is switched off, that should get a ground. But where is it getting the ground from? You know, these 3 we determined are power, so we shouldn't get a ground, and we don't. So that just leaves us with these 2. And both of them are passing a signal to the magneto. So yeah, this doesn't make a lot of sense because this was power. So when you shut the switch off, it's going to send 12 volts into the coils. So I'm not sure how that was shutting things down, but it was. I guess the other thing to consider too is that we were also connected here. So when this is off, you know, does this connect somewhere else? So let's turn this on. So we lost the connection between these 2. And we also lost it between these 2. So yeah, very interesting. But we do have a connection here. So now that is battery positive. If we turn the switch off, we lose it. But if we move it over here, it's now ground. So this pin is switching between battery positive and ground. That was running to the PTO, which technically should be fine. But when in the off position, you know, you need to send ground to the coil. So having these 2 energized like it was, I think was a mistake. You know, we need to energize this with 12 volts, that to ground, this to magneto, fuel solenoid, and starter. This one I don't think is needed in this application, and we only have 5 wires anyway from the factory harness. So let's find which of these is the ground and start there. So similar test, although I'm going to get the non-factory wires out of the way. We're not too concerned about those anymore, and we're left with these 5. So I've got one lead of the meter connected to a source or ground, and let's just see if any of these wires are ground. So white is ground. And so is black. So we need to figure out what the difference is here, because we only need one dedicated ground. Likely the other one's getting picked up through like a coil on a relay. So let me see if I can trace these wires and figure out which is which. So I haven't figured out yet which one is the ground, whether it's the black or the white. Logic would say black, but we don't want to assume. So instead, kind of focused my attention to the red wire. I assume that should be the power coming in. And I think I found my answer. So let me show you what I found. So we have right here this fuse holder that is missing its fuse, but it does have 2 red wires. So logically, you would think the power comes from the battery through the fuse and up to the control panel. So if that's correct, one of these wires should connect over to the control panel. So if we probe it and the meter beeps, then we know that the wire runs up to the control panel feeding power. Now, the question is, the red wire on the other side, that has to be connected to the battery. So the only wire we have is this heavy gauge one right here, which runs to the starter. But on the starter, we have 2 other wires. One is kind of the aftermarket wire, and the other one is actually the only wire from the original harness hooked up. So let's test from there up to here and make sure we have a connection on the other side. All right, so it is very hard to see in here. There's a lot of stuff in the way, but right here, that is the red wire that comes from the battery and connects over to the starter solenoid. The other side of the solenoid connects to the starter motor, and when the trigger wire gets powered, it closes that solenoid and sends the power to the starter. So the light wire here, this used to be red. It's the aftermarket wire. It is sun faded. This is what triggers the solenoid. And this is the red wire that goes into the factory harness and I think goes up to that fuse holder. Now, the thing that's a little odd here is that this is on the trigger side, and I would think that should be on the full-time power side, being that we're going through the fuse, and that would go basically unswitched up into the control panel. That, to me, makes sense to have over here, and then that just begs the question, where is the trigger wire? And the wiring diagrams that I have actually show that the OEM trigger wire is a yellow, but it does run through a relay. So we're going to have to double check that. But I think these are the 2 wires here that we need. This one sends power to the control panel, and this one likely should be connected to the solenoid to crank the engine. So let's just get a lead on there, make sure that the other end of this does in fact go to the fuse holder, and then we'll try to figure out the yellow. And definitely hard to get in here, but let's see if we can get the lead on like that. And same test as before. If that wire down there is what I think it is, we should get a tone on that side, and we do. And we shouldn't get anything on the other. So good. I think we know what one of the wires is. Let's try to figure out the yellow. And I believe it's going to be one of these relays right here. So I already did unplug this one. It's actually in there kind of loose right now, but the relay contacts, they are filthy, so we do need to clean that. We also have a yellow wire, I think, right here on the middle relay as well. So that one we'll pull out and set aside. And let's just see if we can probe on the yellow contacts and see if we get any connection to that yellow wire. So it's not clear just on looking at the relay which terminal is which. So I'm going to probe on the likely candidates. The other end of the meter, it's on the yellow wire up in the control panel. So nothing there. Let's check the middle relay. Nothing there. Yeah, and nothing on those either. So I'm just going to pull all these out. I'm going to spray this down with contact cleaner. And we'll probe around a little bit more. All right, so it's been a few minutes, but I think I finally figured out what's going on here. There's actually two yellow wires going in here. And I didn't see it at first because it was covered in dirt, so it looked black. But we have two, and one of them actually has a black stripe on it. So the one with the black stripe is on the top. That goes to the engine harness over by the engine. And the bottom one, that is a solid yellow, and that goes to the control panel. So if we do the same test, we should get a beep, meaning we have continuity. And we do. Then if we move it to the top, and I move the lead from the yellow wire in the control panel down to the engine harness with the yellow wire and the black stripe. And if we repeat the test, we get a beep. So we now know what those are. I guess the thing that threw me is that, these are not the control wires, the yellow wires. I thought they would be, but the safety systems are the control wires. So when you hit start, if the safeties aren't energizing this solenoid, then the power isn't going to pass through the yellow wires down to the starter solenoid. So I think for now it's safe to put that relay back in. So now we've got 2 wires figured out, 3 to go. So looking down here at the engine harness, I was able to pull these 2 out. They actually kind of came out on their own. The purple wire I cut out, and we have some bare copper here. So if you remember, we do have a fuse up above, another fuse that actually has the fuse in it, and those wires are purple. So I believe that runs up to the fuse. And according to the diagram that I have, the purple wire in the control panel is for the fuel solenoid. So if that's correct, then we should have continuity from here through that fuse all the way up to the control panel. So this is the fuse right here. It's a 30 amp fuse, which seems overkill if it is just powering the fuel solenoid. And the wires, they are purple. So let's test it. Yep, we're good on that side and good on the other side. So let's check it at the control panel. So the purple in the control panel, it's doubled up with the red. You know, I don't know if that's correct or not. The wiring diagram I have, don't think mentions a red, but knowing what we know about the starter relay, that has to get power from somewhere. And I'm guessing that is it, because in the run position, you know, these two wires will be energized pretty much at all times. So let's see if we have a connection. Okay, and we do. So we know what 3 of the wires are: the yellow, purple and red, and the red. So that just leaves us with the white and the black. So one of these is ground. I'm gonna go out on a limb and say that it's black, but both are testing with a ground connection. So we need to figure out for sure which is which. And I guess one other check we can do, which I don't think is gonna tell us much, is to probe from this wire, which is the red and the purple wires, over to the PTO, because this switch has to send power. So it must be picking it up from that red and putting it onto one of these terminals, which appears to be that one right there. So yeah, I think we're on the right track here. So on this harness coming down to the original engine, we have the yellow wire, which is to crank the engine, purple wire, which is the fuel solenoid, and then that leaves these two. So one must be to shut the engine down, and the other one, I'm thinking, energizes the PTO. So yeah, which is which? Yeah, I'm going to say, well, neither one seems like it would energize the PTO, but let's test them. Let's start with the white one. I'm curious to see if that is the ignition wire, you know, meaning it grounds out when we shut the switch off. So let's put a lead on that. And this one might be the hardest of all because likely it goes through all the safeties. But let's see. So yeah, it was kind of a dead end chasing the white wire. It does go into a bunch of relays and switches. So I'm going to rely on the diagram that I have, which isn't quite right, but the pinout seems to match. You know, that diagram says black is ground, which kind of makes sense. And it does confirm that white is to kill sparks. So that might come back to haunt me, but if it's right, it's going to save a lot of time. So let's connect up the wires based on what we learned, starting with the full-time battery positive. So that is in the bottom left. On the right is the ground, which we said is going to be the black wire. The kill wire is the white, which goes right there. The run wire, that is the purple and red, goes on the right side. And that leaves us with the start wire, which is the yellow. So theoretically, we're now back to factory on the ignition switch. And we can even add in the PTO, which only plugs in the correct way. Now, technically, the ignition switch would have had a connector like this. You would have just plugged it in. You know, everything would have been right. But somebody removed that at some point. But yeah, this theoretically should be back to factory. So we're going to get this missing fuse replaced. I'm going to use a 20 amp. I'm not sure what should be there, but for testing, I think it would be better to go with a 20. And we'll probably do the same over here as well. And I think the last thing we need to do here is actually disconnect these wires. This darker red, which is hard to see, that should be actually over here. And the trigger wire is actually the yellow. So we're going to leave that disconnected. We'll just test it with the multimeter. And, that way when we crank the engine, the trigger won't be connected. So technically it will not crank. And those are on there pretty loose. So we're going to leave off the non-factory connection. And for this one, we're actually going to need an eyelet to attach it right there. So we're going to connect this with vice grips. In case something goes wrong, we can disconnect it real fast. Okay, passes the spark test. Well, the good news is we don't have any smoke yet. Of course, I just realized we didn't find the power wire for the PTO, so we have a little more digging to do, but let's turn this to the run position and see if anything bad happens. And no, that was pretty uneventful. Let's try start. Okay, so that's good. We don't have anything connected to the engine, so let's probe it and see if we're getting any power down there. All right, let's test out the yellow wire. I've got the multimeter hooked up, one lead on battery negative and the other one is on yellow, which should be the wire to crank the engine. So if we turn it to crank, we get a connection, or I should say a voltage. So let me switch the meter to read voltage. And right now, let's see if I can move it so you can see. Probably can't see that. But we're at essentially 0 volts. Let's crank the engine. 12.4. So yeah, that is perfect. And let's take this a step further. So we are on the white wire again. If I shut the switch to off, we get a beep. But in the run position, we don't. And right now, every switch is kind of in the safe position, meaning the drive levers are in neutral. So let's move those out of position. And immediately, the right lever triggers the coils to shut down. Let's try the left. And we don't get the same there. But I did hear the switch, or at least a relay, click. So let's try that again. And no. So the wiring might be a little different there. Potentially we have a problem. Also, the switch on the seat, let's try that. Currently it is bypassed. There is a metal wire in the harness, so let's pull that out. See if the beep comes back. And it does not come back, so that might be okay. Maybe that's just a PTO safety. And then we have a parking brake on the far side. So right now it's in the park position. Let's move that out of park, which I would suspect would be fine because the PTO is off. So let's move that out of position. Interesting. So when the parking brake is off, it tries to shut down spark. So why would it do that? PTO is off. I wonder if the PTO needs to be on. I doubt it. But it's on now. Let's try it. Very interesting. So with the PTO on, you can take it out of park. So that park switch seems to work. The right lever seems to work. The switch on the left seems to be dead, but that can be fixed. And then we also have the kill wire again for the seat. So now that the PTO switch is on, let's pull that bypass out and see what happens. And spark shuts down. So good. I think most of the safeties have been restored. As far as the PTO goes, I was kind of at a loss as to where the wire was. I mean, we had most of these wires accounted for, and I think the only exception was the green. So I tested that. That was not it. Not completely sure what its use is in this application with this engine. But then I noticed there is actually another wire that was cut pretty short, and it's a heavy gauge wire. I can't really tell what the color is, but according to the diagrams I have, it's either a purple wire or potentially a red with a black stripe. So this, I believe, is the PTO wire. So let's see if we can test that. And that'll be the final piece of the puzzle. And it's definitely hard to tell what I'm looking at here. I assume this is the wire. It seems to be a very heavy gauge wire, which would make sense for the PTO, but stripping this back is definitely proving to be challenging given, well, the thickness of it, but also how short the wire is. But hopefully this is it. And there actually seems to be two wires in here. So potentially one is power and the other ground, which would make sense. I mean, the hole right there is for the PTO, and that conceivably would have gone through there at one point. But this sleeve is super tough. So yeah, it's going to be a little hard to cut it back, but it looks like the bottom wire might be purple and the top one black. Yeah, definitely a purple and a black. So I'm guessing the purple probably comes right from the PTO switch, and the black, again, probably goes through the safeties. So we could still have issues on that front. I think we have enough exposed that we can probably strip back a little bit and run a couple tests. All right, so let's go for the gold here. I'm reconnecting battery negative. Right now we're showing no voltage. We're going to turn the ignition key on. And we had a momentary blip, but no voltage. Let's hit start. We get nothing. We're in the run position. Let's pull the PTO knob out. And there we go. So yeah, that is in fact power for the PTO. That should be it. And theoretically, we are done. I left all the old wiring in there just until we do the testing, and then we can rip all that out, and we'll be left with just the factory harness. Everything's been reconnected in the control panel. That's been resecured. Everything in here is connected to the factory harness, and we even reconnected the seat switch, which hopefully doesn't come back to bite us. We didn't actually test that. And down here, pretty much all the wires from the wire harness are reconnected. I think the only exception is the green wire. I don't think that's used on this engine. And we're also leaving the charging system disconnected since that needs a new regulator. And the low oil pressure switch, that is disconnected as well. This harness doesn't have accommodations for it, but technically we could probably wire it into the white wire and get the desired effect. But for now, let's just test with the factory harness and make sure everything works. All right, so it is the next morning and the battery is fully charged and reconnected. So I think it's time we actually try this out and see if everything functions as it should. And even though we did a lot of testing with the multimeter, we didn't test every scenario. We know that we should have spark when not sitting on the seat as long as the parking brake is on and the drive levers are in the neutral position. But we didn't test what happens when we're on the seat. I suspect if you're sitting on the seat, you can take it out of park and take the drive system out of neutral. But we didn't test that, and we also didn't test the switch. So those are wild cards. Assuming we make it through that, the final test is to engage the deck, assuming the belt holds out. So, we can't run it for too long. We don't have any cooling, so we're not going to drive around and try cutting anything. But we can run it just long enough to see that things are working as we hope. So let's see if this thing's going to start today. So we'll give it a little bit of juice. And we should be able to start it like this. We're in neutral, parking brake is on. Uh-oh. We just lost power. So I'm thinking that 20 amp fuse may have tripped. All right, false alarm, the fuses, they're actually fine. The thing I just realized is that when we did all the testing before, the seat switch was bypassed. And I actually think you need to be on the seat to crank the engine, which kind of makes sense. So let's try this again. Get started this time while on the seat. In the neutral position, parking brake on. I think we're in business here. You know, all the functions seem to work. All the safeties seem to work. The OEM harness is functioning again. So let's get all the unneeded wires out. All right, guys, and that is pretty much it. So the goal really was to see if the PTO and the deck worked, and that was pretty easy to do. But the wiring was a complete disaster, so I couldn't really send it down the road in the condition that it was in. So we did restore the factory harness. You know, all the safeties are working, and really the wiring at this point is more or less complete. You know, I think the biggest exception is that we do need a new voltage regulator, but those are fairly inexpensive and easy to come by. So I would say, you know, my friend got a heck of a deal for $200. You know, this machine still needs a ton of work, but that is something he is going to tackle on his own. So I hope this video helps someone. Thanks for watching.